Professor Vishnoi from Computer Science at Yale University. So he's going to present Humans Are Not Alone, AI Discriminates Too, Controlling Bias in AI.
Thank you, everyone, for coming here. I'm going to talk about various issues such as bias, discrimination, fairness. These are some of the most fundamental values that humans have held. And as artificial intelligence algorithms are being deployed more and more in the governance and regulation of society, or even through the ways which we communicate with each other, various issues are coming up. So the goal of this talk is to give you a very high-level view of what the issues are, how they arise, and what might we do as scientists, computer scientists in particular, to check the threats that are posed concerning the deterioration of our values. So the central goal of artificial intelligence, or this whole area, is to mimic human intelligence. And this is not something very easy to define. What do we mean by human intelligence anyways? Well, the fact is that when we look around the world, we see that we have various abilities, faculties, which are missing from various biological organisms or even lifeless creatures. And some of them are things like we can see. We have an extremely well-developed vision system. We can communicate with each other both in terms of sound and also things which make sense, such as natural language. We have a language, I have a language in which I'm communicating, and I assume many of you are actually understanding what I'm saying. We have a pretty sophisticated biological structure which includes bones, muscles, and all that around it, which regulates it, which allows us to do incredible things. We have a brain which allows us to think strategically and do things which at least we don't see other species able to do. And we also produce art, literature. So these are some of the things. Some of them are unique to human beings, some of them are not. But the goal of this area is to create computer algorithms which can do some of these tasks. And in some of these we have been successful, and in some of them we have not been successful. Let me give you a very high-level picture of how these algorithms work. With the goal of learning from the real world or learning from humans as to how they actually are able to do. How can we see an image and recognize whether it's a cat or a dog? How does all this happen? And if you want to replicate it, or if you want to create a model for it, we have to first understand to some extent how the human body works. And a central part in that is the brain. And there are models of brain which we use. But the model itself is not just enough. We also learn from examples. You know, anybody who has experience with kids knows that you have to tell a kid, this is good, this is not good, this is a cat, this is a dog. So this is the aspect of training. So when a kid is born, they probably have the model, but they don't know what is what. And slowly, through examples, we train them to recognize. Well, this is one of the first things. We teach them how to recognize objects. And so we need data for that. If we want to replicate this in the world of artificial intelligence, we need labeled data. We need lots of examples of what is it an airplane, what is it an automobile, what is it a bird, and so on. And once you have model and data, still there is this daunting task of finding the parameters of the model, for which you need sophisticated algorithms. So that's where the algorithmic theory comes in. And combining these three, roughly speaking, combining these three things is what gives rise, or what is giving rise to artificial intelligence, which has created a lot of excitement in the world. And so I mean, among the people sitting here, you're all experiencing this revolution, whether you are aware or not aware of it. You're all using things like search engines, including Google or Bing or whatever you use. Many of you probably use things like Netflix, and if you use Netflix, you know that often it has this thing called suggestions for you. So it is learning about your preferences in some in some way and suggesting back to you what it thinks, what the algorithm thinks you might like to see. Uber. Probably some of you took Uber to reach this venue today. Uber is again an algorithmic tool, which is a platform which matches drivers to clients, people who want to take rides. And there is intelligence in understanding and estimating and matching, which underlies its success. In more diverse areas where you may or may not have experience with is maybe is precision medicine, where today specific medicine is developed depending on your genes. And I mean, how do we come to this conclusion that this particular medicine might be useful for you is through learning from data, from patients. Facial recognition. This is also something that if you're using the latest version of iPhone or any other phone these days, they have this ability to take your picture, and if you want to unlock the phone, all you have to do is point the phone towards yourself. And among the more grim, but nevertheless very important applications of AI are autonomous weapons. So these are weaponry which are controlled through algorithms and which are used in areas where humans are hesitant to go and fight wars. So these are a small spectrum of things where you might have experienced personally even AI doing somewhat intelligent things. It's very hard to define intelligence, but you can get a sense that there's something intelligent going on in these applications which is making your life easier, which is creating jobs, which is driving economies. However, and this brings me to the point of the talk, that these algorithms, the AI algorithms, can be biased. And I'm going to give you some examples of studies that have been done recently. So one of the first studies that was done was so one of the first successes of artificial intelligence was to build a classifier. A classifier is an object, is an algorithm which tells you whether a particular element is in some group or not. So in this case, you want to detect a person's face. And this is one of the great successes of AI. But when people started studying how well this algorithm does, depending upon what your gender or racial constitution might be, this is when the big problem in AI surfaced, which is of bias. So in this example, which hopefully you can see, this is one of the classifiers that IBM had put online, and there was a huge difference in the error rates of classification. What does that mean? Well, none of the classification that is being used today is 100% accurate. No algorithm can tell you with 100% accuracy that an image is a cat or not a cat. It can only tell you with certain amount of accuracy. And that accuracy can depend on whether you are a man or a woman, and whether your skin is white or your skin is dark. So this is surprising, and this we will in a little bit in the talk, we'll try to understand why this is happening, why this could be happening, and how we can control this. But these are facts. The error rate in prediction. So what this really means is that if you are a black woman and you look at your iPhone will unlock. You might need multiple iterations for your iPhone to unlock because it has to recognize your face first. Whereas if you're a white man, your life is much easier when it comes to many of these things. Another example is Google search, which probably many of you have used. If you go and search for, CEO or any profession where you and you look at what the images returned are. So in this particular case, we search for CEO, and you see that there is a gross misrepresentation of, at least in the US context, a gross misrepresentation of gender in the search results. So factually, the percentage of US CEOs who are women is 27%, but Google only shows 11% images. And it's not like there's any conspiracy here. It's just the algorithms are not designed to be aware of these issues, and we'll talk more about it. But these are fact studies that people have done, which is pointing out that the information that you're consuming on the internet might reflect various biases. Here's another example where, so if you ever search Google, you see on the right-hand side, something which you probably ignore is a whole bunch of ads that show up. And these ads are targeted to you. These ads show you content or information which you're likely to click on, subscribe to, or go, and if it's a job ad or whatever. And here again, a study showed that women are systematically showed ads which are for low-paying jobs. So for instance, a secretary job versus a manager job and so on, when compared to men. And then these things, it's not even clear that these are accidental things. I'm not going to make any accusations here, but there have been various instances now where it has been established that the things are not necessarily just by accident. These big tech companies often are also aware, but maybe don't act about various issues which could lead to discrimination. And so these are some examples. There are thousands of examples and studies that have been done, at least in the US, in these contexts. So what is the problem? Why does it matter if I go on Google search and search for a CEO and I get to see only white men? What is the problem? Well, the problem is the following. Suppose you are a little girl in India or Africa who at a very early stage is recognized as someone who can be good in science, and so she goes on Google and searches for what a scientist might look like, and when she sees images like this, she probably cannot relate to people, and that discourages it. This is how we work. So the point I'm making is that what we see, the information that we consume on the internet affects our decisions. It affects our choices in life. And these are not some off-the-hook statements that I'm making. I'm not giving references here, but these are studies done by people who are qualified to do these studies, who demonstrate that by looking at, if I continue to show these kinds of images, people's perceptions of professions and the choices they will make will depend on this information. Something, I guess, which is now pretty clear, at least in various countries in the West, is that information has, and how it's shown to use, has the ability to manipulate elections. And in fact, there was a study, a very reputable study, where it was 3 different contexts. One was an Australian context, one was an Indian context, and one was in the US context. And the experiment was something which you might think is very simple. So you bring a person who's trying to decide between 2 candidates who to vote on. And this is a person who already doesn't have a strong opinion, who doesn't have a strong preference. So they're somewhere in the middle. And then you divide these people into various subject groups, and to each group you feed information in different order. It's the same information, same set of articles about the candidates. It's just the order in which this information is presented is different for different groups. So for instance, one group is first shown the positive articles about a particular candidate, negative articles about the second candidate, positive articles about the first candidate, about the second candidate, and then the negative articles about the first candidate. And you can imagine that this is a point where people are forming opinions about a particular person and who to vote on. And they measured that before the experiment and after the experiment, you could manipulate, there's a correlation between the voting patterns of people depending on in what order they saw this information. So it all sounds very scary. The ability of, because somehow we think that these algorithms, we are using Twitter, Facebook, Instagram all the time, and we think that this information is the reality, whereas the reality is something very different. It is reality. It's not what you're seeing is, I'm not talking about fake news or misinformation. I'm just talking about what information you're seeing, because the information you're seeing is some subset of all the information that exists there. And these algorithms are choosing these subsets for you. They learn about you. They know who you are, what your preferences are, and they show you more of what you would like to hear, which as such is not a problem, except that it goes and changes my opinions even further. And that's what you see in various political contexts. I mean, in the US, if you look at, for instance, what the Facebook wall of a person who's left-leaning versus right-leaning about the same set of events that are happening in the world looks like, it's dramatically different. Because these algorithms are catering to people's personal preferences, so they select the news that you want to see. And by consuming that news, your opinions get more firm and more firm and more firm, and pretty quickly, these two groups lose the ability to talk to each other. And this is the problem that we are all experiencing, whether it's US, UK, India, Europe, China, or whatever. So, algorithms, which had such a great promise, I mean, around 90s, 2000s, I mean, most industries or many industries were basing, I mean, they were a boon for us. And from being a boon, they are suddenly disrupting the fabric of society in a variety of ways. They are destroying our fundamental values of equality and fraternity and justice. So from being superstars, they have really been labeled as weapons of mass destruction or math destruction, as this very nice book of Cathy O'Neill, if you want to read more about popular things. And this was taken cognizance by the White House itself in 2016. And in a report which is very influential about preparing for the future of artificial intelligence, it very specifically says that extra care has to be taken to ensure the efficiency and fairness of these systems based on evidence-based verification and validation. So we need to incorporate human values into the design of AI systems. So what is going on, and why do we encounter biases in these artificial intelligence systems? So here's what is happening. So we talked about how the design of an algorithm looks like. Okay, I don't know why it went away, but I need to come back here. So the real world itself is biased. 1 second. Just give me a second. This is not done by artificial intelligence, otherwise it would not be crashing like this. Okay, let me just show you this slide here. There's some small issue with this. So hopefully you will not mind. I'll go back to okay, so what is happening is that the real world itself reflects our our biases.
Actually, it isn't showing on the screen.
It's not showing on the screen at all? You see nothing? Okay. So each step of this process where we are learning a model, selecting data, is where we humans are making a choice. Is it gone again? Okay, I'll just let this slide pass and then I'll switch back to the normal mode. So what is happening is that the real world itself, I mean, humans have been biased. In fact, one of the ways you can view this information is that algorithms are confirming that humans are biased. Because how can algorithms be biased anyway? It's the choices that we have made in their design, right from which data we use to train these algorithms, to what algorithms we use to train them. Each of these involve a particular human taking a decision. So algorithm at the end is a piece of code, agreed, and henceforth there is no human intervention, but that whole design process is governed by humans, and that's why the choices that we are making in this process are leading to these bias. So it's just a way to translate or encode human biases into something which seemingly is objective. But that's what, I mean, that's really a very high level view of why the bias creeps in. It's there in every step. And I guess this loop is very important. We just discussed that biased AI outputs lead to changing the world itself and creating it. It has the potential either to create into a worse and worse place or a better and better place. It's entirely our choice what kind of algorithms we design. So, yeah, I'm going to skip this. So how can we control bias in AI systems? What is bias? What is fair anyways? The problem is that there is no single notion of fairness. In different contexts, and I think this is something everybody has experienced through various interactions. When you're at an airport, you interact with the airlines, or when you are at a bus terminal, or when you're at a bank, you start thinking from, I mean, there are multiple parties involved in these interactions, and if you start thinking from one or the other, you start seeing that there are many notions of fairness or bias, and there are various different contexts. And so one has to control bias in specific contexts. So one popular rule, which is called the 80% rule, it has a grounding in the US legal theory and in fact US legal systems. It offers protections with respect to certain attributes such as gender, race, religion, for certain sectors, public sectors such as employment, housing, and others. And what this rule says, this notion of fairness says, is that if you are selecting a certain number of candidates, let's say for a particular job, let's say employees of a particular organization, and if the number of candidates that you had to begin with were equal, male and female, or this could be multiple types as well, and if you selected at least 10 men from there, then you better have a very good reason to select less than 8 women. If for whatever reason you're selecting less than 80%, if the two classes are not within 80% of each other, then you better have a very detailed and reasonable explanation of why this is happening. And this is not just my opinion, this is the law, which is being implemented and also executed. So this is one particular way in which you could curtail. So now you can go back to your image search application where the actual female CEOs was 26%, but the actual images are 11%. So what is happening is that Google is not really trying to be malicious here. It's not saying, hey, I think this person is a man, so let them show these images or vice versa. It's really trying to show you a set of images which it thinks are most useful for you. So there is a notion of utility in what you're seeing. But because of the data, historical data that it's using, this notion of utility gets biased against women. And this is a complex process. So instead of trying to let it be, one could enforce things like the 80% rule on Google's algorithm. Say that in all of these professions, you need to be at least 80% within the truth, the ground truth. And then the searches, which would really look like this, if you're able to see this, will transform to something more, which is also more real, a real representation or a closer to real representation of the world. So the challenge here is incorporating these notions or values related to fairness or bias into algorithms and designing new algorithms which are aware and which have the ability to correct biases and as a consequence not accelerate people's opinions about various things. Let me give you one more example, which is about personalization. So this is a topic which so how many people here have used Facebook or Instagram or Twitter? Raise your hands. Okay, I see many people. There are some people who are not using or who are not acknowledging because these days it's even not, clear what you should say or you should not say. But that's why I'm using the U.S. context here. So one of the fundamental things which you may or may not know is that these algorithms which are showing you content. So what happens? So you logged into Twitter maybe before this talk, and maybe you log into Twitter now, and since then, a certain number of tweets have been generated by the people who you follow. A large number of them. Okay, depending upon how many people you follow, a large number of tweets would have been generated. But your phone screen is really small, and so the algorithm of Twitter, and this is really their, this is really their prized possession, is an algorithm which will select a small subset of tweets from all the tweets which have been generated since the time you last logged in to the time you log in, and show it on your screen. And this algorithm is using information about you in this process. And let me show you very visually what is happening. So this on the right is like a lot of tweets which have just been generated. There is a content selection algorithm which selects a subset of tweets and creates a personalized feed for you. I say personalized because it takes into account who you are. And then what do? You either, even when you're scrolling, you may or may not be liking tweets, you may not be liking, retweeting or liking or whatever, but it keeps track of even when you're hovering behavior, and based on the amount you engage with a particular type of tweet or news item or feed item, it sends this information back to the content selection algorithm. And then the content selection algorithm updates or learns more about you. And then this cycle continues. So you have to be very careful on what you're clicking, and I guess this you have experienced personally. If not, pay more attention to this. So here's a very simplified graphic illustration of what is going on. So mathematically, you live in some high-dimensional space. You're a point in some high-dimensional space. And this is the space of all news articles which could potentially be shown to you. And the algorithm maintains you, a representation of you as a point in this high-dimensional space. And depending upon, so this person you see in the middle is you in the beginning of the process. So right now, in this simplified example, there are only two extremes, blue and red, and you are somewhere in the middle. And you get to see a feed which you see on your left, which seems pretty balanced, right? It has a fair number of blue and red. But the moment you click, let's say, on a red feed, the algorithm updates its view about you by moving you a little bit towards the red side. Now this is an optimization process, okay? And I can't really go into the details of it, but this is the meta level effect that happens, that if you click a lot of these red posts that you see, you are going to start moving towards red. And your position in this space determines what is the next set of articles you're going to be shown. So the closer you are to certain articles, the more likely you are to be shown those articles. So this is this rich get richer phenomena that you experience. And maybe you clicked on a blue, so maybe you move a little bit to the blue side. But what happens is in this process, and what we are seeing is polarization, which is people's, and this is verifiable, people are slowly moving to the extremes, and the algorithm really thinks that you are somebody who thinks blue and likes blue and drinks blue and eats blue, and you are somebody who thinks red. So the middle ground, which is where the interesting things happen, where the discussions among people used to happen, is not happening anymore. And every time I give this talk, I feel like there are few people who learn about these algorithms. Many people don't know that this is happening, that there is a loop here, that by clicking or hovering even, you are giving signal back to the algorithm. It is learning more about you. And it is choosing content based on what it thinks you would like to see. And in that process, it's also changing your opinion. So this is exactly the rich get richer phenomena happening in this context. So what do you do? Well, one can apply some kind of a variant of the 80% rule in this setting, and what that would really mean is that at no point the algorithm should be allowed to take you to the extreme. Now the question is, who will impose this 80% rule? In this world we live today, governing companies and regulating them is a very challenging task. So what we have done is created algorithms which allow you to self-regulate, for instance. So you can download stuff that we have and use it to self-regulate. If you would like your Twitter feed or Facebook feed to not be completely of one type, you have the knob. But potentially even governments can interfere and say, look, I mean, this is just destroying the society. People can't talk to each other without fighting, and this is not the society we want to live in. So maybe it has to be through some awareness among people that such solutions are possible. People like us are working on such solutions and studying the impact of such solutions on, can we bring back the society or not? I mean, this is really a terrifying thought, and we experience it more and more. But there are algorithmic solutions towards controlling bias in things like personalization. And this is a growing area. There are many, many computer scientists working with social scientists and others, regulators, who are trying to understand what the problems with these things are and how we can design new algorithms to control bias in artificial intelligence, bias in various forms. So I'll conclude. The three take-homes from this talk is that AI is everywhere. It's no longer your choice. I mean, whether you are taking an Uber, whether you are watching movies, whether you are searching online, whether you are getting your news, AI is being used in selecting content, matching you, allocating resources to you. And this AI, because of the choices humans have made in their design, unknowingly or knowingly has gained the ability to encode human biases and make them even worse. But the good news is that bias can be controlled. It's not too late, perhaps. And an even bigger goal, given the fact that we live in this kind of a loop where human behavior is being controlled by algorithms and algorithms are being controlled by humans, there is a possibility that we can turn back the clock and bring it to a point where people can still talk to each other without getting into arguments. Anybody who has seen Twitter feeds on contentious topics or even non-contentious topics these days, or Facebook feeds, knows exactly what I'm talking. There is no conversation going on in these things. People are just shouting at each other. Nobody's listening anymore. So there is a very great opportunity here, especially for the youth, to engage in whatever way you can to control, especially social media, and self-regulate. But it's also very challenging because it's no longer the case that this is a problem that falls in the domain of computer science. So computer scientists are the architectures of these tools, but that in some sense is the problem because we didn't take input from social scientists, regulators, psychologists, philosophers, people who have been thinking about equality for thousands of years and design systems which optimize profits, utility, accuracy, and have paid no consideration for human values. So I think it's time to bring back some of these values, and there is a lot of people working in this area. It's one of the most exciting areas to be in. It's the area, I think, which will save humanity, if at all there is any hope. And with this, I'll conclude my talk. If you want to see more about the kind of work we are doing, you can visit these web pages. You'll get an idea of the kind of tools we have developed, the kind of activities we are doing. But this is a very broad area. I encourage you to search about it and learn more about how you can control bias in AI. Thank you for your attention.
Thank you, Professor Vishnoi. So the floor is open for questions.